So how do you find the equation of a plane if you're given 3 points? Well, so remember, to find the equation, we need 1 point, and we need a direction. Right? So those are the two things. And remember, that direction is actually perpendicular to the plane. Okay, so how are we going to put all of these together if all we have are 3 points? So I've just labeled 3 points, P, Q, and R here, and it's flat, but right, it could be oriented any direction. So 3 points out in space, right, will define a plane. Okay, so I'm going to go ahead and lay it flat again so we can just kind of see how it works. So, right, well, we have lots of points to choose from, right? Pick P, Q, or R to be your point. How do we get the direction if I want to be perpendicular to this plane? So I want you to think about what you know about vectors and how we get something perpendicular. Right? So I'm going to make a vector there, and I'm going to make a vector over here. Okay. And everybody remembers, right, that PQ, if I find that vector, and I cross it with vector PR, cross product leads to a vector, and that vector is perpendicular to these two. So when I cross these, that will give me that normal vector, right, perpendicular to the plane. So if it's flat, it comes out like this, right? If it's angled, right, my plane isn't flat, even when I cross them, right, that normal vector will be coming directly out at 90 degrees to the plane. Okay, so let's go ahead and grab 3 random points. So we'll find the EOP that contains the points. So P can be the point. How about 5, 0, 1? Q can be the point. How about -2, -3, 4? And we'll let R be the point 0. Doesn't really matter, to -3. Okay. So I'll let P be my anchor. Doesn't matter. Pick 1 point to be your anchor. So I'm going to find vector PQ. Okay. So 2 minus 5, -3 minus 0, 4 minus 1. Okay. Now we're going to find vector PR. So 0 minus 5, 2 minus 0, -3 minus 1. Check my arithmetic in there. Okay. So I have the 2 vectors that are in the plane. Okay. So now when I do the cross product with these 2, that'll get me the vector that's perpendicular, that's orthogonal, that's normal. All of those mean the same thing, okay? Perpendicular, orthogonal, normal. I'm using all of those interchangeably. Okay. So cross product, so we want PQ crossed with PR. I, J, K across the top. Remember, then we'll write the components of P and PQ, components of PR. And we'll go ahead and cross. I think I'll do it down here just because I kind of wrote that big. So I hat. Okay. So I hat, and then it's -3 times -4, so 12 minus 6. Then it's minus j hat. I get rid of these guys. Okay. And then it's 28 minus -15. You see that? 28 minus -15. So 28 plus 15. And then plus k hat. That'll be -14 minus 15. Okay, so let's go ahead and tidy that up. So I'm going to have 6i hat minus 43j hat minus 29k hat. So that means my normal vector, 6, negative 43, negative 29. You can absolutely leave it like this with the i's, j's, and k's. I'm just kind of getting ready to write it with my, write it in my other form, right? Because what we were asked to find, by me, was the equation of the plane. I just know the direction, right? So the things I need a point and I need a direction. Okay, we have the direction now. Pick one of these to be the point. Doesn't matter which one. And then the way we do it, either you're going to do the cross product, right? Remember how you do the dot product between your point and some other random point in the plane, okay? Or we can do 6x minus 43y minus 29z equals, and then to get d, we take n and we multiply it by, I'm going to choose p because it's got a nice 0 in there. So 6 times 5, 30, negative 43 times 0, so that's gone, and then 1 times negative 29. Okay, so 6x minus 43y, oops, sorry, scooch, minus 29z equals 1. And so you'll see, right, this is true for all points on the plane, okay? So you can plug in any one of the P, Q, and R, and it will make this true. So let's do one more. So let's go ahead and grab 3 points. So P, how about 2, 7, negative 6, 0, 0, 4, and R can be negative 3, 2, negative 3. So come up with your vectors. PQ. So negative 2, negative 7, negative 10. PR. Negative 5, negative 5, 3. Okay. Cross product to find n. So vector n is PQ cross PR. I hat, j hat, k hat. Negative 2, negative 7, negative 10, negative 5. You can get rid of those negative signs as long as you get rid of all of them. Just a lot of times it comes out in the wash when you do your cross product here. So I hat is going to be negative 21 minus 50. Well, not there. Negative 21 minus 50. How about negative 71? And then minus j hat. Negative 6 minus 50. Oh dear. Negative 56. And then k hat. I get 10 minus 35. So my normal vector, negative 71, positive 56, negative 25. Well, that's an odd vector. That's okay. It's still fine. We've got lots of points to choose from. I'm going to go ahead and grab Q because it's got lots of zeros. So the way we do our vector then, it's these is right, A, B, and C. The way we do our plane, AX plus BY plus CZ equals D. Here are my A, B, and C, so negative 71x plus 56y minus 25z, and then D is equal to, right, A times, right, your point. So I have A negative 71 times 0 plus 56 times 0 plus negative 25 times 4. So D is going to be equal to negative 100. So equals negative 100. I'm going to make that look nicer. Those negative signs are bothering me just because there's so many. And if I multiply both sides by negative 1, I can make this look just a little bit neater. Okay, so that's how you can find the equation of the plane if you have 3 points.